Okay, we've done a quick review of the Pythagorean theorem, and now we're going to get into distance and then midpoint. I'm going to do distance first, which is numbers 8 and 9, and this is on page 59 in the book. So it says, using the distance formula. We don't care about the distance formula, that's just saying using Pythagorean theorem. Don't let the directions complicate things. Find QR, which is right here, and ST, which is right here, to the nearest tenth. Then determine if, and this says QR is congruent to ST. Okay, so we have two distances to find. I'm going to find QR first. Okay, I'm going to actually draw this on my own coordinate grid just because it's easier for me to work with. So Q is at 1, 2, 3, 4. 1, 2, 3 is at 4, comma 3. So I'm going to put that 1, 2, 3, 4, 1, 2, 3. Right there's my Q. Okay. R is going to be at 1, 2, 3, so it's negative 3. You can't see that very well, but that's okay. And then you go up 1, so it's positive 1. Negative 3, positive 1. Okay, so the first step is to get the coordinates of your points, and that's going to help you to figure out the distance between them. I'm going to attempt to draw a straight line on here. Okay, we're looking for that distance right there. Now, when we're drawing distance, the most basic way to think about this is that you're drawing a right triangle. So I'm going to draw my right triangle here. I'm going horizontally first, and then I'm going vertically. Okay? I'm going to use the coordinates to figure out how long the sides are. So here, for this side right here, we know that R is at 1 because of this number right here. That's how high it is. So this is 1. And Q is at 3. So the distance between 3 and 1 is 2. If you want to see this mathematically, we're doing 3 minus 1. Whenever you find distance, you're subtracting. Okay, midpoint is adding. So 3 minus 1 is 2. That means this side right here is 2. Now we need this length right here. So we know that this is at negative 3, and we know that this side is at 4. So from negative 3 to 4, there's 7 spaces. From negative 3 to this y-axis, we go 3, and then 4 more makes 7. To show it mathematically, we're doing negative 3, 4, I'm putting subtraction in between them, and that makes negative 7. So I'm going to write negative 7 right there. So that means that my A is 2, my B is negative 7, and the hypotenuse, which is the distance that we're trying to find, is x. So really we're doing exactly the same as the Pythagorean theorem problems. The only difference is that you have an extra step of drawing the right triangle. Okay, so I'm going to take my parentheses. Okay, A is going to be 2. B, now this is something I didn't mention just now, but I should. Distance can never be negative. If I tell you to cut negative 7 centimeters of string, you're going to look at me weird. So we know that the difference between negative 3 and 4 is negative 7. That means that the actual distance is positive 7. Whatever number you get here, you just make it positive. That's called taking the absolute value. Okay, so I put a 7 right here. And this is my x, is the hypotenuse. 2 squared is 4. 7 squared is 49. 4 plus 49 is 53. And then, of course, my last step is to do the square root. And I'm done. That's that whole problem. It's not that bad. Well, that's the whole QR. Now remember, if we look back at the directions, it says to also find ST and see if it's congruent to QR. So what you need to do is go back to this problem and look at ST. You get the coordinates, and then you find the distance, and if you get a distance of square root of 23, then they are, I'm sorry, square root of 53, then they are congruent. If you get something different, then they're not congruent.